Today we are going to discuss about indexes. What is index and why this will be helpful? For example, we are having 2, 3, 4, 5, 6. Like this data out there. This much data is there in one table. Okay. So whenever we are fetching the data, so you are giving where number equal to 99998. So this number you are fetching in select query where number equal to 9998 99998. So this number you are searching in where condition. Okay, in this situation, so what Oracle will do, it will search from starting onwards. So if you give this condition, select star from table name where number equal to 99998. If you give this condition, it will search from starting onwards. 1, 2, 3, 4. It will search everything, and where the number will found, till there the searching will happen. So once the number found, then it will display the result. Okay, so from start to end, how many searches it will do? 99998. This many searches it will do. It will check here, it will check here, it will check here, from starting to end, top down approach. It will search and it will fetch the data. So this will cause a so much time it will take to fetch the data, whatever our required output. It will take so much time. So this will take the full table scan. Full table scan it will take. Instead of that, if we want to search the data in random manner, we need indexes. We need indexes if you want to search the data in random manner. Means random manner means, so instead of searching from starting to here, okay, we need to fetch the data in random fashion. So for this, indexes will be helpful. There are some types of indexes. One is B-tree index. Second one is bitmap. Function based index. Fourth one is reverse key index. So mostly nowhere the reverse key index will be useful. These three only important. B-tree, bitmap, function based indexes. Okay. And this will indexes will comes under the performance tuning topics. Okay, performance tuning to reduce the to increase the performance of the query. Then what we need to do? So in that there is one first point is indexes. Okay. Now how to check the query performance, everything we will discuss now. I'm creating some two backup tables now. To create employee copy, same like employee table. Mahendra, can you tell me the query?
Hello.
I want to create an employee copy table, same like employee table.
ತಿಳಿದೇನ ಪ್ರಿಪೇರ್ ಆಗಲ್ಲ ಸರ್.
Pradeep, Varun,
Yes, Raghu.
yeah, tell me the query. Okay, tell me who knows this.
అన్న నేను చెప్తా.
అన్న రఘు ఈ ఎంప్లాయ్ నుంచి అది పేరు మారాలి అంతేనా? అదే డేటా మొత్తం మారిపోవాలి అంతే కదా?
Yes.
సెలెక్ట్ ఎంప్లాయీ
అన్న నేను చెప్తారా?
చెప్పు ఆదిత్య.
క్రియేట్ టేబుల్ ఈఎంపీ, ఇది ఈఎంపీ కాపీ ఎంప్లాయీ టేబుల్ టార్గెట్ టేబుల్ యాస్ సెలెక్ట్ స్టార్ ఫ్రమ్ ఈఎంపీ.
That's it. Simple. So first check whether employee copy table is there or not. Star from. So there is no table. Now we are creating same like employee table. This is the query. Table created. Now check. Table is there. Same like I want to create a department copy. Same here, DPT copy. Yeah, department copy table created. Okay, so now if you want to see the performance and if you want to see the execution plan, we are having execution plan means how the query works background. So we are having, there are two types. One is explain plan. For explain plan, you need to mention explain plan for this select query. So first I am writing this select query. This is nothing but I have joined two tables, employee copy and department copy, and where department number 10. I'm saying that is only, this is simple select query. Okay, now I want to see this execution plan for this. So how to see that? We need to explain first. Explain plan for this select query. Okay, plan has explained. Now where to see? This is the table. Select the plan table output from table dbms explain dot display. This is the table. This is the execution plan for the table. What it is here? So don't worry about this. This everything will be taken care by DBS only. But for knowledge purpose, how indexes are working, how the performance tuning will check, how the execution plan of the query will check. So I'm explaining that. So this is the plan hash value. So for every select query, there will be a plan hash value generated by default. Okay, and here we can see department copy. We have created one query select query. So for that department copy, full table scan. EMP copy, full table scan. Table access full means I have given a select query department number equal to 10. Okay, I want to search only 10th department number. But when I see in query what it is taking, total employee table it is taking scan, and department table also it is taking full table scan, and it is fetching the results. And CPU cost also see. This is the CPU cost for this query. This much CPU has been utilized for the simple select query. Okay, this is execution plan. So same thing I have copied here. This is the execution plan of this query. Okay, and the second one, how to see the execution plan? auto trace. Set auto trace on. One thing is explain plan. Second one is auto trace. Set auto trace on. So if I say this, and after this I am executing the select query, same select query, automatically you can see here execution plan. If you use set auto trace on, automatically you can see the execution plan. Okay. This is first before creating the indexes. This execution plan looks like this. Okay, before creating the indexes on the table. This is the CPU utilization, and this is taking full table scan, and this is also taking full table scan. Okay, now I am creating the index. Bit tree index I am creating. Create index name on employee copy. So I'm creating them. So first you need to check for which column you need to create an index. Okay, that we need to analyze first. So here in query, I have used e dot department number. E dot means employee copy. So whatever we are using in where condition. So for that only we need to create index. So if we create a salary column, there is no use because we are not using in a where condition. If we use in where condition, that is okay. Okay, so here I am using department number in where condition. So I am creating department number, employee copy department number. I am creating index. First, where you check indexes whether index created or not. It's sorry, auto trace off. User underscore indexes. Tables where we can see. If we create one table, where we can see how many tables are there. Next time. Now for employee copy, there is no indexes on the indexes. Now I am creating the index. Create index D number on employee copy department number. Department number column, I am creating an index. Index created. Now check. Yeah, now index is there. Employee copy table. There is a index name. This. Now index created. Now execute the select query. Same select query. Execute now. Why we are using set auto trace on? After this, if you execute the select query, automatically you can see the execution plan downside. For that, I am using set auto trace on. See, I have executed select query. The results also came here. Results also I can see. With the results, you can see the execution plan also. So this is after. Sorry. This execution plan is after we created an index on the table. See See the before index, what it is taking, table scan full, employee copy table scan full. But here table scan department copy is full, but index employee copy table access by index row ID. See the CPU cost. CPU utilization is 0. Here CPU utilization is 20%. But here CPU utilization is 0. So if the CPU utilization is 0, reducing, then the performance will be increased. So here there is less row, so that we cannot see any difference in execution of time. But if there is any more records, it will be helpful. The time will be reduced, the query execution. And here one thing we can see, the CPU cost has been reduced. CPU cost has been reduced here. See 0, 0, 0, 0, 0. But before index, it is 20, 20. Okay. Now this will be improve the performance. So for that we need to create an index. Any doubts? What I am doing, I am checking the execution plan of the query first. Before creation of index, I have checked the execution plan. Next, I have created the index. After creation of index for the same select query, I am checking the execution plan. Here we can see the improvement of the query. We can see the improvement of the query. So here CPU utilization is less. Here CPU utilization is more without index. And here it is taking full table scan. Full table scan means it will search the, like I said previously in first example. So like this, if there are records, okay, if there is no index, it will search from starting to end, starting to till here, it will search. If you use in where condition, this number, it will search from starting to end. But for the same column, if you create an index, it will search randomly this number. So the CPU cost will be reduced and the performance will be improved and the query execution time will be less. Okay, so this is the execution plan after creation of index. Now here we have created, that is a B tree index. This is the B tree index. Clear everyone?
Yes, yes.
So indexes will be improved.
అన్న B tree అంటే డేటా స్ట్రక్చర్ అట్లా
B tree and tree wise.
ఆ,
Just wait, I will show you that also. I have a document. Everyone know, right? Row ID.
yes sir డ్యూయల్
What is the row ID?
అంటే ఆ టేబుల్ యొక్క ఐడి రిట్రీవ్ సెలెక్ట్
Select row ID, comma.
Row number.
So for every record, there will be one row ID automatically created by Oracle. This row ID means physical location. This data is stored somewhere else, right? So where the data stored, that physical location address, row ID is the physical location address. Okay, so here, if you see here, this is the B tree index structure. These are the leaf branch blocks and leaf blocks. These are the row IDs. These are the row IDs. 0 to 40, 41 to 80, 81 to 120, 200 to 250. So if there are 250 records in one table, okay, the 250 records, first when we create a B-tree index, Oracle internally it will stores with the row ID in the branch blocks. It will store with the row ID like this. See, 0 to 40, 41 to 80, 81 to 120, 200 to 250. Again, it will divide it into, so first to 0 to 40 block, it is divided into, see here, 0 to 10, 11 to 19, 20 to 25, 30 to 40. Again, next block, 41 to 80, it is divided into like this. Next to 200 to 250, it is divided into like this, 200 to 209 like this. Next to leaf blocks. For this 0, there is one row ID. For this 0, there is one row ID. 1, there is a row ID. 10, there is row ID. 11 row ID, 12 row ID, 19 row ID. Like this. All records is stored with the row ID here in leaf blocks. Okay. So you are searching in 250 records. You are searching 50th record. For example, 50th record you are searching in their condition. So the query will come here and directly it will go into the this block. Okay, instead of searching 250 records, directly the query come here because 50th record in this block only. 50th record will be there in this block. So now 41 to 80, how many records it will search? Only 40 records it will search. Instead of 250 records, it will search only 40 records. So there the search will be reduced and the performance will be improved. Okay, like this. In leaf blocks, it will store internally. Okay, just for knowing purpose only, I am explaining. So it is not required actually. How the internally stores, that is everything DBS will take care. So it is not required for knowing purpose. How internally indexes will be happen, that I am explaining. So as of now, you should know only how to create index. That's it. Syntax of creation of index. So previously, whatever I have told, the execution plan, everything, that also you should know, but that is not a mandatory. Everything you need to remember is how to create index, this part. That's it. So if this everything I'm explaining, how internally indexes will be worked, how internally performance will be improved when we create indexes, that everything I'm explaining. This is the B-tree index. If we create a bitmap index, so this is the bitmap index. Okay. Why when we create bitmap index? There are 1 million records. 1 million records in one table. Okay. There are columns, serial number, serial name, and gender. 1, 2, 3, 4, like this. There is 1 million records. Name also like this one, A, B, C, like this, 1 million. But in 1 million records also, what will be the gender? Either male or female. B, C. This last record 0, 0, 0, 0. Gender is okay. So in 1 million records also, gender will contain only male and female. These two only. Apart from that, there is no chance to for the next word. Okay, in this scenario, in 1 million records, you are giving condition. Anything test, select start from test. selector equal to male. So I am fetching only male records only. In this 1 million records, I am searching only 1 million only male records only. Okay. When you are searching this, the 1 million records will be searched here, one by one record. This record will be searched. Okay. And this is the male. Okay. And this will be searched. And this is the female. This will be searched. This is the female. And this is searched. And this is the male. Okay. Only male records will be fetched. So for that, without index, if you fetch, it will take so much time and the performance also degrades. If we create a bitmap index, okay, if we create a bitmap index, when the creation of index only, like this, the data will be stored. M means male, F means female. So for first row, first row there is male, okay, it is appended with 1, and second row there is a female. So for male, it is appended with 0. 0 means false, 1 means true. Second row there is a female, okay, 1. Third row there is a male. So for male it is given 1 and female 0. Row 4 male is there, so true. Row 5 male is there, true. Row 6 female is there, for female true. Row 7 female is there, so for female true. Okay, like this internally it will store if you create a bitmap index. Okay, and when you're searching, when you select star from text where gender equal to male, so all 1 records will be fetched, all row, all 1 where M is there, and row 1 means true, so all male true records only will be fetched. So this will not fetch. So that is the benefit. That is the benefit of the bitmap index. Clear, everyone? This will be a little bit confusing only, but you just remember the syntax, how to create a bitmap index. I am explaining how the bitmap index will be work, everything I am explaining. So that is the creation of bitmap index. Select create bitmap index, employee bitmap index. This is the index name on index table, sorry, table name and gender format. This is the creation of bitmap index. Clear, everyone? This index topic. Index is nothing but to improve the performance of the select query. Okay, instead of fetching data, instead of full table search, if you create index, it will search the data in random manner and it will give the results quickly. That is the benefit of index. And there are types of index: B-tree index, bitmap index, and function based index. Reverse key index is not that much important. B-tree index we have seen how the internally how B-tree index will be work, and bitmap index also we have seen how internally it will work. And next, function based index. Function based index is nothing but in where condition using some functions, upper of ename, lower of ename. Okay, upper of ename, lower of ename, init cap of ename, some functions you are using in where condition. So every time so you want to search the employee names in upper letters. So every time you are writing in where condition upper of ename. So instead of writing every time upper of ename, you can create a bitmap index. Sorry, you can create a index on this function. Employee copy upper of ename. That's it. For this function, I have created the index. That's it. There is a function based index. There is only syntax difference. Everything is same. This ends our index topic. Any doubts?
కొంచెం కన్ఫ్యూజన్ గానే ఉంది బ్రో.
బిట్ మ్యాప్ ఒక్కసారి చెప్తారా ఇంకోసారి?
బిట్మ్యాప్ ఇండెక్స్. ఓకే, ఇది టేబుల్. ఫర్ ఎగ్జాంపుల్ దిస్ ఇస్ ద టేబుల్. Okay, in this table I am separating only one column. I am taking only one column here. Gender. There are the records male, female, female, male, 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 female. Like this there are records. Okay, so if you don't create an index on this, you have not created any index on this. So you are searching, select star from test. This query you are fetching where gender equal to male. If you give like this, so how search engine will works? First it will come here, first record. Yeah, this is male, and this is also will search. Female also will search. Male also will search. So all records. If here there are 10 records, the 10 records will be searched. So in that, whatever the male records are there, that only will be displayed here. But if you create a bitmap index, you have created a bitmap index. So internally it will store. So you have given gender equal to male. So for male, it will give 1. 1 is for true. For female, 0. For female, 0. Male, 1. 1. 0. 0. Because here we are searching with gender equal to male. So that is the reason in table internally it will store wherever the male is there, it will store with 1. 1 is for true. True means, yeah, that is the male record. 0 is for false. Okay, now how the search engine will works? You have given this where gender equal to male. So directly it will not search all records. It will not search all 10 records. It will search wherever the 1 is there, wherever the true records are there, that only it will fetch. Okay, 0 records it will not touch. 0 is for false. It will not touch the 0 records. And in scenario, if gender equal to female, then reverse. For male it will store 0, and for female it will store with 1. 1 is for true, 0 is for false. Okay, like this it will store, and records only 1 records only it will fetch, and it will give the result. Zeros it will not touch. Now clear?
Yes.
అన్న ఇప్పుడు ఫిమేల్ అంటే ఫస్ట్ నుంచి చెక్ చేసుకుంటూ వస్తుంది అది.
ఫస్ట్ నుంచి చెక్ చేయదు. ఇప్పుడు నువ్వు బిట్ మ్యాప్ ఇండెక్స్ ఉంటే, ఒకవేళ బిట్ మ్యాప్ ఇండెక్స్ లేదనుకో, అసలు ఇండెక్సే లేదనుకో ఈ కాలం మీద, అప్పుడు ఫస్ట్ నుంచి చెక్ చేస్తుంది. ఈ ఫస్ట్ రికార్డ్ చెక్ చేస్తుంది. సో ఇది మేలు, సో ఓకే, అది రిజెక్ట్ చేస్తుంది. నెక్స్ట్ సెకండ్ రికార్డ్ సెట్ చేస్తుంది, ఫీమేల్, ఓకే, ఫీమేల్, ఓకే. నెక్స్ట్ మేల్, నాట్ ఓకే, మేల్, నాట్ ఓకే, మేల్, నాట్ ఓకే. Like this, from starting to end, all records it will search if there is no index. If you create a bitmap on index on this, it will store like this 0 1 1 1. It will store internally first only. Okay, but how it will fetch? All ones only it will fetch data. Only 4 searches will happen here. If there is 10 records, it will search only 4 records only it will search. But if there is no index, all 10 records it will search. That is the difference with index and without index. So here with index, without index, you can see the difference also here in execution plan. See, this is without index, the CPU cost is more, and with index there is no CPU cost only. Now clear?
Yes, Raghu.
You also create at your own index, and after that see the execution plan, how it is working. So better you can create with more data. So here I am searching with only 15 records. I'm creating with only 15 records. So better you create at least 100 records or 200 records on your own and search and create index and see the difference. Okay. Now you should have one doubt. How to insert 100 records. Hello.
అన్న బిట్ మ్యాప్ ఇండెక్స్ అనేది జెండర్ నేమ్ మీద కాకుండా డిపార్ట్మెంట్ నేమ్ మీద ఇచ్చామనుకోండి ఎడ్యుకేషన్ ప్రాసెస్ ఎలా ఉంటుంది?
సార్ డిపార్ట్మెంట్ నెంబర్ మీద ఇచ్చాము. డిపార్ట్మెంట్ నెంబర్స్ వచ్చేసి 10, 20, 30, 40, 50, 60, 70 ఇలా ఉంటుంది. ఇలా ఉన్నప్పుడు నువ్వు బిట్ మ్యాప్
రిపీటెడ్ గా ఉండే డిపార్ట్మెంట్ నెంబర్స్ కూడా ఉండొచ్చు.
ఫర్ ఎగ్జాంపుల్ ఈ టేబుల్లో ఓన్లీ 10th డిపార్ట్మెంటే ఉంది. 10, 20, 20 ఓన్లీ 2 డిపార్ట్మెంట్సే ఉన్నాయి. ఓకే, ఇచ్చుకోవచ్చు. 2 అనే కాదు, 3 డిపార్ట్మెంట్స్ ఉన్నా ఇచ్చుకోవచ్చు. కానీ ఇలా ఉన్నప్పుడు ఎక్కువ డిపార్ట్మెంట్స్ ఉన్నప్పుడు టేబుల్ సెలెక్ట్ స్టార్. సో హియర్ 10, 20, 30 ఇలా డిపార్ట్మెంట్ నెంబర్స్ ఉన్నాయి కదా. ఇలా ఉన్నప్పుడు ఎక్కువ డిపార్ట్మెంట్స్ ఉన్నప్పుడు సో యూ షుడ్ గో ఫర్ బిట్ ఇండెక్స్. మోస్ట్లీ ఇవి ఎక్కడ యూజ్ చేస్తారంటే బిట్ మ్యాప్ ఇండెక్సెస్ జెండర్ కాలం, లైక్ జెండర్ కాలం. Gender is one column and in some table there is a year column and month column. Year, not only year, month column. So in month there are static fixed 1, 2, 3, only 12 months are there in a year. 7, 8, 9, 10, 11, 12. Only 12 months are there. We know this cannot be increased or this should not be increased. Okay, only 12. So year only will change. 2000 year 1 first month, 2002 1 first month, 2002 first month, like this there. So we want to see irrespective of years, you want to see data. Select star from test where month equal to 1. You want to see only January month data. Okay, so in that time if you create a bitmap index, how it will happen? All one data, all first month data it will create with 1 and remaining all month it will create 0. 0 is for false. Only this month data only it will fetch. Okay, but here why I am not suggesting for department numbers? Because department might be increased. It is not a fix. So department for tomorrow they will come and they will create a new department and a new department will be added. So for that I will not suggest. In this scenario you should go for B-tree index. In this scenario this month are fixed only, so there is no extra month, there is no 30th month will come, right? So there are only 12 months. So that is the reason for that. Like this in gender column also there is male and female. If it increased there will become transgender. Okay, these 3 only. Apart from these 3 there is nothing will be added. So for that scenario we can create a bitmap.
బేస్డ్ ఆన్ సినారియో మనము ఏ ఇండెక్స్ అనేది సెలెక్ట్ చేసుకోవాల్సి ఉంటుందండి.
అవును, ఫంక్షన్ బేస్డ్ ఎప్పుడు యూజ్ చేస్తాం మనం? ఎప్పుడు వేర్ కండిషన్ లో ఏదైనా ఫంక్షన్ యూజ్ చేస్తున్నప్పుడు. సో అప్పర్ ఆఫ్ ఈ నేమ్. సో సెలెక్ట్ స్టార్ వేర్ ఆఫ్ ఈక్వల్ టు king. సో నేను ఇలా వేర్ కండిషన్ లో నేను కొన్ని ఫంక్షన్స్ యూజ్, నాట్ ఓన్లీ అప్పర్, ఎనీథింగ్ యూ కెన్ యూజ్ ఫంక్షన్. సో ఫర్ దట్ సినారియో we can go for function based index. Clear?
క్లియర్ అండి.
Now previously I told, so create your own records, 100 records or 200 records and create index and see, I told. Now how you will insert 100 records or 200 records in table? I'm just asking normally. So tell me how you will insert 100 records in one table.
SQL loader.
It's only insert into test. Yes. 3, 4, 5. 100 times you will write insert statement.
సీక్వెన్సెస్ ఉపయోగించి కూడా
Sequence ఉపయోగించి నేను ఓన్లీ ఇక్కడ సీరియల్ నెంబర్ నేను ఎగ్జాంపుల్ తీసుకున్నా. ఫర్ ఎగ్జాంపుల్ ఇది నేమ్ అయితే A01 like this. So if it is 100, okay, you can write insert statements 100 times. That is okay. But if it is more than that, 1000 or 1 million, then 1 lakh, then you will write insert statement 1 lakh time. No, right? So there will be one utility. There will be one Sql loader. Sql loader concept is there. Okay, for SQL in every scenario, like in any projects, first process is data loading. Second process is data fetching. Third process is optimization, query optimization. Okay, so wherever you go, wherever the project, banking project, insurance project, wherever you go, so you will have only these steps. First data loading, in any the project, data loading, data fetching, optimization. So data loading means from source to target. First the project comes with data loading. Somewhere to somewhere we need to load, right? So we are having tables in our database. Okay, in tables we need to load the data. Load the data means the data should come somewhere. The clients will send the data. How they will send? Flat files. Flat files means either txt files or csv files or txt files or csv files. Anything comes under flat files. In flat files we will have data, and this data we need to load into our tables. From flat files we need to load into our tables. Okay, for that SQL loader will be helpful. Okay, you have loaded the data from flat files to your table. Once the data is available in your table, okay, you need to load into the different transaction tables this data based on the requirement. Once all table data is having, then after that we need to fetch the data as per the requirement. Fetch the data means we need to create a select queries as per the requirement. And last one, optimization means query optimization. So if is there any query is taking so much time, we are having some performance tuning techniques. Based on that we can use the optimization. So in that one part I have told now indexes. Okay, these are the process in every project and in every company. This is the process, everything. So now our first step is flat files. Flat files to table, how we will create by using SQL loader, that we will discuss now. What are the prerequisites for SQL loader? To load the data from flat files to database, SQL loader will be helpful. The required for SQL loader, what we required for SQL loader? First control file, .ctl file. Okay, .ctl file I will show you how to create. And next flat file with location. Okay, we are loading the data means there should be somewhere, there should be file somewhere with location. That location also we required. And file equivalent table in our database. Okay, there is one file we need to load into our database. So to load the data, to load into database we need table, right? File equivalent table. that is also required. And SQL Loader command. SQL Loader command is required. This is the 4 steps we required. Okay. First, I'm creating the database table. My number, ename, salary. I'm creating one database table. Select start with test. Table is there. So this is okay. Third point is okay. File equivalent table. Okay. Now we require flat file with location. So here I am having this is my flat file, for example. So this is I required from client side. 104, 105, anything. So like this, 100 records you can keep here. This is the flat file. This is the flat file I required from client. So I'm just showing only 3 records. Okay, for better understanding. 3. These are the column. Employee number, employee name, salary are the column, and these are the values. Okay. So this is the flat file, and this location. This is the location. F drive file 1. F drive file 1.txt. Okay, this is also completed. Now these 2 steps are completed. Third step is control file. Control file is very important to create the control file. This is the syntax. Syntax to creating the control file. Load data. This is the syntax. In file. In file, path of the flat file. Path of the flat file means this one. Next, insert, append, truncate, replace. So here I will use insert. Insert into table name. What is our table name? Test. So insert into table test. Fields terminated by delimiter. Fields terminated by means 1 minute. Okay. Fields terminated by means so I'm having flat files. This is each column is divided with the pipe delimiter. This is the pipe symbol. Okay, pipe symbol delimiter. So this is I'm using here. Delimiter. Delimiter means if there is a comma delimiter, so we need to give comma. If there is a pipe symbol delimiter, we need to use pipe symbol. That's it. Optionally enclosed. This I will tell you later. So first I am creating a simple SQL loader. Now control file. Load data in file. Path of the file. Insert into table. System.txt. System is my user. Test is my table. System.txt. Fields terminated by. Fields terminated by means here I am having delimiter as pipe symbol. So I have given pipe symbol, and after that our database table columns: employee number, employee name, salary. So this is the control file I have created as a .ctl file. See here I am having. See here CTL file. CTL file is nothing but you can save notepad as a .ctl. See here what is there in this. I opened this. See, this is the .ctl file. Okay. Why I am using option skip 1 here? If I use this, if I use this option skip 1, see here in our flat file, what is there? First column, employee number, e-name, salary. These are the, this is there. Okay. So if you don't use this, if you don't option skip one, so it will not skip the one value. For one record, it will skip. If you use option skip one, if you use option skip two, it will skip the two records. If you use option skip three, it will skip the three records like this. Option skip one is it is for skipping the header. Load data in file, insert into table, fields terminated by pipe delimiter, trailing null calls, e number, e name, salary. These are the column. This is the control file. Control file is there in one path. Flat file is there in one path. My database table also present. Everything is there. Path of the control file is F drive test.ctl. This is the path of the control file. Okay, now my 3 points are done. I'm having control file also. I'm having flat file with location. I'm having file equivalent table in our database. Okay, these are the prerequisites. Now we need SQL Loader command. SQL Loader command. This is the main important syntax. SQL LDR user ID equal to username password, control equal to path of the control file, log equal to path of the path of the log file, bad equal to path of the bad file, discard equal to path of the discarded file. What is this thing? These all things I will explain here. I'm using SQL Loader. User ID equal to system.manager. My username is system, password is manager. I'm giving control file path. My control file, where my control file is present, F drive. F drive, this is the control file. I'm giving that path. Next one is log. Log file path, where the log should be created, that path. Where the bad file should be created, that path. Where the discarded file should present, that is path. Okay. Now everything is there. I'm executing this command. Where we need to execute this? In command prompt, in CMD prompt. In CMD prompt, first check in SQL plus whether data is there or not. Start from test. Okay, no row selected. Data is not there. I'm executing this SQL LDR command. Okay, it is done. Now check whether the data is there or not. Yeah. Now the data is present in table. And so here we have used a log file path. F drive test.log. See whether the log file is present or not. See here. This is the log file. What log file will do? So this will give everything. SQL Loader started, control file path, data file path, bad file path, discarded file path, number of records skipped 1, total logical records skipped 1, total logical read 5. So everything this will store. What are the columns are there? Everything will be stored into the, when it run 11/29 Sunday October. So everything will be stored into the log file. Okay. Now what I'm doing, I'm truncating the data. Get table, just table truncated. Start from test. Okay, no records are there. Describe test. So there is employee number is number of 5. But what I'm doing in my In my flat file, I am giving the last record as bad record. Means last record I am giving 10000. 6 digits I have given. Will it insert? Actually, employee number in table, there is a number of 5. Size is 5 only. But here I am trying to insert 6 digits. Will it insert?
ఇన్సర్ట్ అవ్వదన్న.
Should not insert, but we'll see what will happen. Close this, and again, see here, I'm deleting the log file also. Now there is nothing is there. With the name of test, there is only control file. Again, I'm executing the Sql Loader command. Sql Loader command executed. Now see in table whether the data is present or not. Data is there, but that last record is not inserted. Okay, then how to know? How we know that whether which record is skipped, everything? So you can check in log file. Log file automatically created. So in log file you can check 4 rows successfully loaded, 1 row not loaded due to data errors. Okay. What is the error? See record 5 rejected. Error on table, column employee number. ORA error, value larger than specified precision allowed for this column. This is the error. So this everything we can see in log file. And what bad file will do? So here extra bad file also created. See what bad file will do. Here we can see what are the rejected records. See the rejected records we can see here in bad file. Okay, that is the log file and that is the bad file. So this log file, to generate the log file and bad file, we have given in command only. In Sql Loader command only we have given. See log equal to log file path. Bad equal to bad file path. Discard equal to discarded file path. Clear? Anyone having any doubts? There is another one, constant. There is constant option is there. Constant means to store the default values. Means let's say here I'm truncating the table again. Truncate table test. I've truncated the table. Test, no data is there. Describe. I want to add an extra column, location. How to add in an event?
Alter table.
Alter table test,
Modify.
not modify. I want
Stitch
to
mod.
add
Not add. Okay, okay. Sorry.
location var_char2. Yeah. Tabular view does not exist. I have added script test. So now the location is there. So for all data, but here in our control file, sorry, in our data file. So I'm remove this to everything again. In our file, only there are 3 columns only, but in our table there are 4 columns. Okay, so every time that location should be Hyderabad only, or every time that location should be Mumbai only. So for that scenario, what we will do, so this data is same only. In control file, we will change. In control file, I'm changing. I'm adding extra column here. Location, constant. Constant Hyderabad means constant means this is the default value. See, let's run and see will this work or not. I'm executing the Sql Loader command. Completed. Log file created. See here, you can see values Hyderabad. 5 rows successfully inserted. And see in table. There all records are inserted in table. Clear everyone? Any doubts
Yes,
on
bro.
Sql Loader? Clear, right, everyone? If everyone clear, I will give task. I'm giving one bank data. This is the South African bank data, real-time data. This is the bank ID, bank report, revenue, city, year. These are the columns. And this is the bank ID, bank report. This is South African bank details. This is the revenue, and city is Uganda, year. Tanzania, Uganda. This is the Namibia. These are all cities. This is the data. So you need to create the table and you need to load the data. And you can show me tomorrow. Is everyone okay to do this task?
Okay, brother.
I will upload this file in Drive. So you can download from there and you can create a SQL loader. By using SQL loader, you need to load the data. First, you need to create one table. Give the table name anything. These are the columns: bank ID, bank report, revenue, city, year. Okay. Any challenges?
SQL loader లో చేయాలా బ్రదర్?
SQL loader.
ఓకే.
Do this. If anyone have any doubts, you can ask in next class. So with this, we have completed the SQL topics. From tomorrow, we can start with the PLSQL. We will start PLSQL tomorrow. PLSQL, there are the topics, anonymous blocks. These are the PLSQL topics. We'll start tomorrow with anonymous files. So try this SQL loader. If anyone having any doubts, you can reach out to me tomorrow's class. Clear, everyone?
Yes, Raghu.
We'll stop the session. Bye.